अच्छा चलो ठीक है, ये स्टार्ट यार, आवाज आ रही है, ये स्टार्ट कर लेते हैं ये पेपर।
जी सर आ रही है।
अच्छा सो दिस इज February March 21, ठीक है, February March 21, एक समय ऐड करना। अच्छा February March 2021 क्वेश्चन पेपर 2-2। तो स्टार्टिंग विद द फर्स्ट क्वेश्चन के वो कह रहा है कि दैट्स यू हैव टू ड्रॉ द एनर्जी डिस्ट्रीब्यूशन, बोल्ट्जमैन डिस्ट्रीब्यूशन, ठीक है। तो ये क्विकली एक्सप्लेन करो व्हाट आर द टू एक्सेस बोल्ट्जमैन डिस्ट्रीब्यूशन में। Anyone, Boltzmann distribution, what are the two axes? ये कौन सा एक्सेस होता है?
Number of particles and energy.
ठीक है, तो एनर्जी वाला एक्सेस है, this is your energy axis, and the other one is the number of particles, right? And it has a very specific shape, so the shape is something like this. Three खराब हो गया, just a second. So the shape is skewed होती है, ठीक है, something like this. And in the Boltzmann distribution, you've got at low energy you have fewer particles. At higher energy you also have fewer particles, ठीक है. High energy के ऊपर you're going to have fewer particles. Most particles जो होंगे they will be at the most probable energy. This is the most probable energy. Just if you're at room temperature, so most of the particles will have a temperature around 25 degrees centigrade. So high energy के ऊपर कम particles होंगे, low energy पे there's going to be fewer particles. Label. Now you draw a second curve at a higher temperature. तो क्या होता है? What happens if you take it to a higher temperature? What's going to happen?
It shifts towards the left.
नहीं, right की तरफ. High energy पे number of particles. High energy पे number of particles increase, and low energy number of particles they decrease, and the curve becomes flatter as well. State two assumptions of the kinetic theory of particles. Kinetic theory as applied to ideal gas. What are the two assumptions of an ideal gas?
So the first one being negligible intermolecular forces.
ठीक है, so there's negligible intermolecular forces between particles. What's the other one?
The volume occupied by a single gas particle is negligible compared to the total volume.
Volume occupied by the gas particles, not a single gas particle, but generally gas particles. Volume occupied. By gas particles is negligible compared to the total volume occupied by the gas. That's compared to the total volume that is occupied. There's some other assumptions as well. What are other assumptions apart from these?
All the collisions are elastic. The particle behave as rigid sphere, and the temperature is tightly proportional to kinetic energy.
ठीक है. I said you've got 2 grams of krypton is placed in a 5 dm cube container at 120 degrees centigrade. Calculate the pressure. So this is PV is equal to nRT. So we have to figure out what pressure is. So how do I calculate the moles? N is moles. So kya hoga? That's 2 grams divided by the molar mass. Okay, krypton. What is the molar mass of krypton? Anyone? Periodic table hai, that's krypton. So, okay, krypton is 83.8. Okay, that is what the atomic mass of krypton is. Achha, R is 8.31. Achha, what temperature should we take? क्या होगा? What's the temperature?
So 120 plus 2737.
So that's going to be what?
393.
So that's 393. Then you have divided by volume, right? Volume should be in what? Volume is at the moment 5 dm cube. What is the unit for volume?
Meter cube.
Meter.
So वो क्या होगा? 5 times 10 power minus 3. ठीक है? Remember dm cube to meter cube, that's divided by 1000. So find out what this is and you'll find pressure, which will be in pascals.
15.58 into 10 raised to power 3.
Into 10 power 3.
G.
ठीक है, or 15.6. Next one is state and explain the conditions at which krypton behaves most like an ideal gas. So when do gases behave like an ideal gas?
Low pressure, high temperature.
So low pressure and high temperature. So state कर दिया आपने, ठीक है? Now explain why would it behave as an ideal gas? What happens at low pressure, high temperature that a gas starts to behave ideally? Okay, what's
अगर temperature high होगा, they can easily break the intermolecular forces and they can behave as a gas.
so higher temperature means basically both of them basically mean the same thing. That is that they have negligible intermolecular forces. So both of them, low pressure में भी वही होगा. Low pressure means the particles would be far apart, right? So if they're far apart, then obviously they'll have negligible intermolecular forces, because the further they are away from each other, the lesser the attraction. Is that clear?
Yes.
So दोनों का यही है. Low pressure, high temperature, it means the same thing. You're going to have negligible intermolecular forces, and therefore it's going to behave as a gas. The further they are from each other, yeah.
Is it okay to write the volume one for pressure?
Yeah, that's also okay. I mean, you can state that as well. Okay, let me open the MS for this one. Where's the? So either of this, one is van der Waals or intermolecular forces, they become negligible, insignificant, and the volume of particles also becomes negligible when you are at low pressure. Okay, so gases की जो एक property है, that is that they have big gaps between them. So at low pressure, they will have a lot of gaps, a lot of empty spaces compared to the volume of the container. So you can write that as well. Okay, is that clear?
Yes, sir.
As the next one, you have to, this one is an easy one. You just have to draw a label diagram. So this one is endothermic. So endothermic में क्या होगा? It's going to be at a they would be gaining energy overall. So the products would be at a higher energy. Delta H is all arrows will start from the reactants. So that's delta H, and then you've got activation energy. So activation energy will be this, the energy that is initially needed. So that kind of covers this one. You can even state the values over here. Now the next part is explain in terms of activation energy and the collision of particles how an increase in temperature affects the rate of a chemical reaction. So how would you describe this? Higher temperature, what happens? And explain in terms of activation energy and the collision of particles. So what happens at higher temperature?
More collision take place, the bonds are broken, and we get the product.
Like stepwise, you have to answer at higher temperature. First thing, you have more kinetic energy, right? So what happens is that more particles have energy that is greater than activation energy. Okay, more particles have energy which is greater than activation energy. Because remember, if particles don't have energy greater than activation energy, then the reaction will not happen. So if they are at a higher energy, graph ke andar bhi na, if they are at a higher energy, for example, if this is the activation energy, so previously at a lower temperature, you had fewer particles which had high energy, right? But when you increase temperature, the number of particles at high energy, they will increase. So you now have more particles having energy that is greater than the activation energy. So that is one thing that happens. So you've got more kinetic energy, more particles of energy that is greater than activation energy, which is why you'll have more frequent and effective collisions or successful collisions. And successful collisions. Okay, is this clear?
Yes, sir.
Yes, sir.
So now chlorine is a reactive. How does chlorine help in water purification? Does anyone know the reaction of chlorine with water? Kya banta hai? When it reacts?
Chloric
and
one acid and
HCl.
hydrochloric acid.
The HCl plus
HOCl.
HCl. Okay, that's in your notes. Just 1 second. Let me open the notes. So group 17, it's where's water purification? Chlorine kills bacteria because chlorine reacts with water to form HCl and HClO, which is chloric acid. And this chloric acid is basically what kills bacteria. How do you figure out the? You have to write an equation for the first ionization energy of chlorine. So what is the equation? Kya hoga? It's going to be
Plus 1 electron gives Cl minus.
nahi, lose karega wo. Firstly, it's going to be gas, and it would lose 1 electron to form a +1 ion. And you have to remember to, state symbols are very important in this, although it's 1 mark. Why do ionization energies increase across a period? Like if I go from group 1 to group 2, then 3, there's a dip, then 4, 5, 6, there's going to be a dip, and then 7 and 8. So why do the ionization energies increase when you move across the period?
So the atomic radius decreases and the proton number increases.
Mainly the number 1 factor, that's proton number increases, proton number or the nuclear charge increases, right? You have more protons when you move across the period. What else should I write over here? That's the one main
Can we
factor.
say that the number of shells are same?
Okay, so you can state that constant shielding, same number of shells. So which is why always write this at the end. Which is why there's going to be more attraction. Because of the above 2 factors, there's going to be more attraction between nucleus and the valence electrons. Next one, state and explain the relative thermal stability of the hydrogen halides, where X is Cl, Br, or I. So I've got HCl, I've got HBr, and I've got HI. Which one is the least stable? Which one is the most stable?
HI is the most stable.
नहीं. किसका bond weak होता है? Small atom, big atom?
Bigger atom.
ठीक है,
सही
weak.
समझा दे.
नहीं, bigger atom जो होता है, that forms a weak bond, right?
Okay.
Smaller atom, they always form a stronger bond. So this is going to be stable. It's very hard to break an HCl molecule into 2. This is going to be stable, and that's going to be less stable, or you can say that it's unstable. मतलब इतना unstable होता है HI के it's in the notes as well that HI is so unstable with HI that it's very hard to even form it. वो form होता है so it eventually breaks down into H2 and I2 back again because bigger atoms they always form weaker bonds. And there's a reason for that. Why do bigger atoms make weaker bonds? Firstly, there's a lot of shielding, more shielding, right? So I don't think they're going to go into that much detail with the answer, but the atom is more shielded, so there's less attraction for the shared electrons. Because of that, there's going to be less orbital overlap. And because it's bigger, the bond length is also greater. So that means the atoms are going to be far away. So there's going to be less attraction if they're far away. So there's going to be less orbital overlap, longer bond length. So I guess you don't really have to go into that much detail. It's just a 2-mark question. I'll just quickly check. This one was, that's it. Bond strength decreases. That's it. You just have to write bond strength decreases. That's the next one. Tell me the oxidation states of sulfur over here in all these 3 compounds. What is the oxidation states of sulfur? Like what's sulfur over here? Because the HSO4 minus 1. What is sulfur?
+6 is it?
+6. DK Shifa, it's not +8, it's +6. It's H is +1. This is X minus 2 times 4, right? And the total charge is equal to -1. So X is the unknown. So if you solve for sulfur, it's going to be +6. What about SO2? What's the oxidation state of sulfur over there?
+4.
Okay, that's going to be +4. और यहाँ पे H2S. Not +2.
-2. Oh, sorry.
Yeah,
नहीं सर -2 क्यों है?
-2 है. -2
क्यों?
है, right? H is +1, so +1 times 2. Sulfur is unknown, so that's X, and the total charge is equal to 0. So X kya aayega? That's going to come out to be -2, right?
Okay.
So it's going to come out to be -2. Anyway, so H2S, it's -2. So +6, +4, -2. Explain, now he says, explain why you get different sulfur containing products when each of these halides react with H2SO4. So again, this is part of your group 17 notes. What happens is, uski mein puri explanation de deta hu. What happens is, firstly, you've got halides, right? Now, halides don't like to lose electrons, at least the top 2, fluoride and chloride. They don't like to lose electrons. They're smaller atoms, smaller ions, less shielding, so they attract electrons very strongly. Lekin jo bottom wale na, bigger ions, they are more shielded. They can lose their outer electrons, and they really like to lose electrons. So Br-1 and I-1 are very good reducing agents, and they like to lose electrons. ठीक है, पहला तो ये. So Br-1 and I-1, they like to lose electrons. F-1, Cl-1, they hold on to their electrons. They don't like to lose electrons. So what happens with sulfuric acid is that NaCl does not undergo a redox reaction. It only undergoes a displacement reaction, where what happens is that the H+1 ions from sulfuric acid and the Cl ions from NaCl, they just combine to form HCl gas, and there's no change in oxidation state. There is no redox reaction because Cl-1 does not like to lose electrons. So it does not participate in a redox reaction. But when you go down the group, Br-1 and I-1, they become really good reducing agents. They like to lose electrons. So they undergo a similar displacement reaction. But what happens is that they end up with HBr and NaHSO4, but Br-1 really likes to lose electrons. It turns into Br2 and the sulfur gets reduced. I-1 is an even better reducing agent. it really, really likes to lose electrons. So in that case, sulfur gets reduced by a much bigger amount, which is why you get H2S. So what is happening is Cl-1 did not like to lose electrons, so did not get a redox reaction. There was no reduction, there was no oxidation. Br-1 and I-1, they became really good reducing agents. So that is what you're going to write. That why are you getting different? In the first one, there's absolutely no redox, but in the next one, there is reduction of sulfur. In the next one, there's even further reduction of sulfur. So what's happening is, down the group, the halides, it's just a 1-mark question, right? So down the group, the halides become better reducing agents. Is this clear?
Yes, sir.
Tico, remember, ये वाला जो question है, it's definitely going to come in your paper. It comes in almost every paper. So they become better reducing agents. Now, what is meant by disproportionation? क्या होता है? What's disproportionation?
So is this the process that produces sodium chloride?
It is, but what is disproportionation? It's when the same element gets oxidized as well as reduced.
Oh, okay.
So it gets oxidized and reduced at the same time. Then you have write an equation for the reaction. Now this is again group 17, Cl2 with cold. So remember, I'll just wear the notes. So again, Cl2 with cold NaOH, that's going to be NaCl, NaClO, sodium chlorate 1, and water. Cl2 with hot NaOH, it's going to be NaCl, NaClO3, and H2O. So over here, remember bleach. The reason these two equations are important is because bleach is very important. Bleach is something that's industry. It's an antibacterial. It's used in a lot of washing powders, etc. So it's a very important chemical, and this is bleach. So it's how bleach gets produced. Now he's talking about the first one with cold NaOH. So you just have to remember this equation. That's about it. So the equation for this reaction is going to be with cold NaOH. It's going to be NaCl, NaClO, sodium chlorate 1, or bleach, and water. And it's going to be 2 NaOH just to balance it. Now, the next part of the equation is draw a diagram to clearly show how this is dimerization of Al2Cl6. So what happens, he says clearly show all the types of the bonds. So we've got AlCl3, and in AlCl3, what happens is that aluminium's outer shell is not complete. At the moment, aluminium's outer shell needs 2 electrons. So if there's another AlCl3 molecule, let's say if there's another AlCl3 molecule, the Cl will form a dative bond with aluminium. Cl has a lot of lone pairs. It's going to form a dative bond with this aluminium. So aluminium needed 2 electrons, and this aluminium gets 2 electrons from this Cl, and this aluminium over here gets 2 electrons from this Cl. So you've got so that's your 2 dative bonds, 3 normal covalent bonds, not 3, 6 normal covalent bonds. Describe what you would see when aluminum chloride reacts with water. So what happens when AlCl3 reacts with water? And what would you see? That's the question. So what's going to happen? What would you see?
Aluminium
White
hydroxide.
PPT.
Okay, so it's going to be what? White
Aluminium hydroxide and HCl is reduced, and then you have
AlOH3.
Strongly acidic, is it, sir?
Yeah, it's going to be strongly acidic.
Gas.
You're going to see fumes of aluminium hydroxide. Now, actually, remember this one. Previously, this equation, remember there were 2 equations. Previously, this equation was simply that you had aluminium hydroxide forming and HCl fumes getting formed, right? So those are your misty fumes of HCl, and there's going to be a solid precipitate, which is still acceptable. But they've kind of changed this equation slightly to this thing, that aluminium first dissolves, and it forms a complex with water molecules. And then that aluminium water complex, it disintegrates and becomes this thing. This is neutral and releases 3H plus 1 ions. So what you can write over here is that you've got aluminum chloride. So that's, do you know what the color of aluminum chloride is?
No.
White or group 1. And transition metals are the only things that are usually
Oh,
colored.
okay. Mm-hmm.
So first thing is that this white solid will dissolve. White fumes of HCl are going to be formed. You can't write acidic because they just want you to figure out what you see, right? And there's going to be a white solid formed as well, white precipitate formed.
Sir,
हाँ जी.
जो HCl आपने बनाया है वो aqueous है या gaseous है?
दोनों होंगे. Remember, whenever HCl is formed, it's obviously aqueous. It is very soluble. But whenever HCl is formed in a very large quantity, it will form fumes because it is generally, it's a gas. Okay, it's a soluble gas.
Okay.
So some of it will obviously dissolve, but a lot of it will be forming gas. What is the type of reaction? What is this type of reaction? The reaction
which one are we supposed to write?
I mean, the second one. Ab jo hai na, this is the second one that you have to write. I don't think in this question you had to write the equation, but in some marking schemes, definitely both are acceptable. But the recent ones are following this one. Okay, what they say is that aluminum chloride dissolves in water, it forms this complex, and then it hydrolyzes, combines with OH ions, releases a few H plus ions that makes the solution acidic. Okay, is this clear?
Yes.
Yes, sir.
That's the next one. Okay, they weren't even asking for the equation. Now, what is this reaction called? The type of reaction?
Hydrolysis.
Okay, this is called hydrolysis. Now, next question. He says that there's a 0.02 moles of element Z. So there's Z. Kitne moles are? That's 0.02 moles, right? It reacts with an excess of Cl2 to form 0.02 moles of a liquid chloride, and the liquid chloride has the formula of ZClN. So it reacts with chlorine to form ZClN. And that liquid chloride also has the same moles. So it's 0.02 moles as well. So Z forms 0.02 moles of a liquid chloride, which is ZClN. ZClN then reacts with water at room temperature to give an acidic solution. So what kind of acid would it form? I think it would form HCl, right? Well, we acid banega, ZClN reacting with water. So it's definitely going to form an acidic solution, and that's acidic solution is definitely going to be HCl. So if I have NCLs, so how many HCLs will it form? It will form NHCLs, right? You clear?
Yes.
Achha, and
Yes,
then he reacts with silver nitrate to form AgCl solid. So then he does another reaction with silver nitrate and he forms AgCl solid. Wo bhi N nahi honge na? NAgCl solid, right? So basically ZClN dissolves in water, forms an acid. So if there's NCLs, there's going to be NHCLs, right? And if you react it with silver nitrate, it will form a precipitate of AgCl. So if there's NHCLs, there's going to be NAgCLs that are going to be formed, right? Acha, ab aage aa jao ke he's asking you to figure out what N is. And he gave us, the only information that he gave us was this information. And the other information that he gave us was the quantity of the AgCl, which is 11.54 grams. So kitne moles ho gaye 11.54 grams? That's what's the MR of AgCl? That's Ag, I think it's 107.9. And Cl is 35.5. So, बताओ, how many moles do we get for this?
0.080.
0.08, right?
नहीं सर, 1 मिनट, गलत है.
E होगा, 0.08 is making sense. इसे check कर लो, double check.
Okay.
You need 0.08?
जी.
0.080, correct, sir.
Yes, it's 0.080. So he's asking calculate the value of n. So what is n then? Like, what's the ratio? It's this will also be 0.080 moles, right? Because it's the same ratio, n, right? So it's 2:8. So that is basically what? That is
4.
1:4, enough. So that means one of this will produce 4 HCls. That's the ratio, right? So n has a value of 4. Is that clear?
सर एक दफा फिर रिपीट करवा दें.
Last part clear? 0.02 moles is producing 0.08 moles, right?
जी.
So that means one is producing how much? 4 HCls, right? Kya ratio? That's one produces 4, right? So one produces 4 HCls, so n is basically 4. So this question mein tha ki 0.02 moles diya hua tha, and then he stated that HCl is getting produced. I figured out that if you have ZClN, the amount of HCl that's going to be produced is going to be n HCl, right?
Yes.
Or AgCl jo produce hoga, that's also going to be n AgCl, right? So the next thing is you were able to figure out 0.08 moles. This was also 0.08 moles. You were able to figure out this ratio. It came out to be 1:4. So that means one of this produces 4 HCl. So n has a value of 4.
Okay.
That's the next one. You can't say mechanism with this one.
Sir. So the type of bonding in Z, is it giant molecular? Sir?
I just saw bonding. What do you think is the type of bonding? That's it's just, and the structure as well. First thing, type of bonding, is it covalent or ionic?
Covalent, sir.
Covalent.
Why?
Because it's with a non-metal.
You ionic bhi ho sakta. What is Z? Didn't tell us what Z is. Here's the hint that it's a liquid chloride. So what does that mean? It's ionic hota to kya hota? It's going to have high melting and boiling points, right?
Yes, sir.
Liquid means that it's got a low melting and boiling point, right?
Oh.
So it's got a low melting and boiling point. So low melting and boiling point is covalent, right? And low melting and boiling point is a simple molecular lattice. क्योंकि अगर giant होता फिर तो it would have been a solid, and it would have been a strong solid like diamond or graphite or silica, right? Is that clear?
Yes.
Yes, sir.
So structures where that's simple molecular, so it probably has weak intermolecular forces, van der Waals forces, or something like that. So it's going to be simple molecular and it's going to be covalent. As the next one, which mechanism is this?
Free radical substitution.
Together, this is free radical. What is the condition for this reaction?
UV light and Cl2.
Condition the Cl2 is already given, so it's just UV light.
Okay.
What is the electronic configuration of a Cl radical? Cl radical. Cl has 17 electrons. So how many electrons will a Cl radical have?
So is it equivalent to Cl minus 1?
Nee, remember, it's a trick question basically. A Cl radical is basically a Cl atom. A Cl atom has 17 electrons. What is a radical? A radical is something that has incomplete outer shells, right? It's got unpaired electrons. So that is what a radical is. So a Cl atom is basically a Cl radical. So it has 17 electrons and the electronic configuration is going to be 2s2 to be 6. 3s2 and 3p5. ठीक है तो ये clear है कि a Cl atom and a Cl radical are kind of the same, basically the same thing. Is that clear?
Yes.
Okay, Cl
Yes,
minus
sir.
one, Cl minus 1 is not a radical because it's got a complete outer shell. It doesn't need electrons. It has no unpaired electrons. ये जो dot होता है ना, that shows that it's got at least one unpaired electron. Now identify the products of the step labeled propagation 2. What basically happens in a propagation step? वो मैं explain करता हूँ फिर से. What happens in a propagation step is, okay, first step you get Cl radicals, right? Now those Cl radicals are very reactive because they're short of a bond, right? So this Cl radical over here, it basically needs electrons. So it goes and steals hydrogens from the molecule, right? So it forms HCl, and the carbon becomes a radical because carbon's bonds are now incomplete and it's got unpaired electrons. ठीक है, तो idea clear है कि this is what happens in a propagation step, that a radical comes in, steals atom from the other molecule, becomes complete itself, but the other one becomes a radical. So propagation step 2 is same thing will happen. The carbon is a radical, so it's going to attack the Cl, it's going to steal Cl atoms. कितने चाहिए उसको Cl atoms? I mean this one. It's got
One more.
one more, right? CS2, Cl2. So its bonds will be complete, right? But the Cl molecule will then be, it will only have one Cl atom. That will be a radical because its bonds are now incomplete. The propagation steps, there are always two propagation steps and they just keep on repeating over and over again. You have a first propagation step where the Cl radical attacks a molecule, steals the hydrogen, forms HCl. The carbon becomes a radical. The carbon radical then goes and steals chlorine atoms from the chlorine molecule. It becomes incomplete. You get a substitution product, but the Cl radical becomes again. It becomes a radical back again. And it just continues. So that's your product for propagation 2. TK, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
As the next one, name the type of reaction. What is the final step called? The final step.
Termination.
TK, that's called a termination step. So termination is that any of the free radicals that are formed, they could just combine and they could form a molecule. Suggest the identity of another organic molecule that is a product of the reaction. So he's saying, figure out any other product apart from this one. तो और क्या product हो सकता है apart from this one?
From the same reactants.
Like in this free radical substitution reaction, free radical substitution में तो कुछ भी हो सकता है ना. It's any number of
Is
Cl.
it possible कि Cl radical को ही Cl radical के साथ combine कर दें?
नहीं, वो तो reverse हो जाएगा ना. That's just the opposite of this.
अच्छा.
नहीं, वो show नहीं करना. Remember this that in free radical substitution you get a number of Cl substituted products. It could be
So CCl4 is okay.
CCl4 is also fine, right? So it could be all three of the hydrogens getting substituted by Cl, or all four of the hydrogens getting substituted by Cl. ठीक है? Is that idea clear? It could be any number of Cls.
Yes.
वो तो चलता रहेगा. It's just a repetitive process that just keeps on happening, right? So it could be any number of Cl2. Remember, is not a product. ये भी हो सकता है कि it could be two radicals like this combining together. Like you could have a CH2Cl radical and you have another CH2Cl radical. दोनों के bonds complete नहीं है. They could just bond with each other. So that could also be your product. So बस वो Cl change कर दो, you'll get different products, right? So that's this one. Let's move to the next question. You've got this question. P is C4N2, so it's C4N2, right? He's saying the enthalpy change of formation of CO2 is minus 384. So CO2 enthalpy of formation is minus 384. And you don't know what the enthalpy of formation of P is. So that is unknown. So I'm going to take that as X. Do you know what the enthalpy of formation of O2 is?
0.
Okay, that's 0. Elements, you don't need to form them. N2 is also
0.
0. So Abhijuta, if you also know the enthalpy change of this reaction. So what is the formula if you're given the enthalpies of formation of all the reactants and products?
Product minus reactant.
So the enthalpy change of the reaction is basically the enthalpy of formation of the products. You can construct a Hess cycle as well, but let's go with the formula. They didn't ask us to construct the Hess cycle. So enthalpy of formation of products minus reactants, and that's basically equal to your enthalpy change. So your products are what? 4 times minus 384? The other one is 0. Minus your reactants are just X. And the answer should be equal to minus 2036. So the answer is minus 2036. So figure out what X is. Okay, that's 4 times minus 384.
Minus 1536.
कितना आ रहा है 1?
नहीं अभी टोटल नहीं फाइंड किया 1 मिनट.
Sir, it is exactly 500, sir.
Yes.
Plus or minus?
Plus.
Plus.
ठीक है, plus 500. Remember to write positive and negative signs when you're, I mean, make it a habit. I mean, negative signs you obviously write. Positive भी लिख दिया करो, ठीक है. Why is nitrogen so unreactive? Well, what's the reason why nitrogen is unreactive?
So very strong bonds within the molecule, the triple bond.
And
So
it requires high energy to break it.
So it's a very strong bond. Large bond energy. अच्छा इसके ऊपर marks मिल जाएंगे, but there's one more reason for that. If it's a 2-mark question, what's the other reason for that? Why is it unreactive? It's non-polar as well. So it's not going to attract. Like carbon monoxide is also, it's got a triple bond. It's got a pretty strong triple bond. I think that's stronger than, but that is very reactive. Why? Because it's extremely polar and it attracts or gets attracted to electrons and positive charge. So it's very reactive.
सर ये नॉन पोलर क्यों है?
क्योंकि dipoles cancel out हो रहे हैं ना.
Okay.
ठीक है, equal electronegativity है. So that's why it's non-polar. As the next one, what's usually a weak bronzoluric acid? That's weak means ionizes partially or dissociates partially. Acid is a proton donor. So it's a proton donor that ionizes partially. Over here, he's saying that draw one pi bond in an HCN molecule. So this is what an HCN molecule is. Pehle to mujhe tell me, you just have to draw one pi bond. Tell me how many pi bonds does this have?
2.
और कहाँ पे?
C और N के बीच में.
Okay, so you just have to draw one. So what you're going to do is this is C, this is N. They've got that's H. Pi bond is 2 p orbitals in parallel and they would be overlapping with each other. So that's what your pi bond is. So that's it. You just have to draw this. Okay. जब भी वो pi bond कहेंगे, that's it. That's what you draw. Next one is you've got identify 2 absorptions and the bond that correspond to these. P and Q can be detected in the atmosphere by infrared spectroscopy. Identify 2 absorptions and the bonds that correspond to these absorptions that will appear in the infrared spectrum of both P and Q. So both with P. Okay. So both P and Q. So both of them have, what is going to appear in both of them? That's a CN. Both of them have CN. Both of them also have C triple bond C as well. So इसके लिए table होता है infrared spectrum. Where's the? I think I had the data booklet open. So where's this one? So you're going to get an absorption at C triple bond C, and that's going to be at 2150 to 2250 wave number, and you're going to have an absorption of at Cn as well. So you're going to have an absorption at 220 and 2250. So you just have to quote both these values. That's it. Common bonds, you know? So you just have to quote these two values from the table, and that's it. Clear?
Yes, sir.
C single bond CV, I think you should quote that one as well. Where's the C single bond C is there? They don't have that in the table. So there's no C single bond C anywhere. So yoga. Next part, I think that's we just at the maybe here. So next one is there's a flow chart and some reactions of R are shown. So ये कौन सा अभी भी part चल रहा है ना? So page number कर ही लेते हैं सारा. Just give me 1 second. Reaction 1. What's the type of reaction 1?
Addition.
Yeah, addition polymerization.
So that's addition polymerization, right?
Yes, sir.
So then you have 1 second. Just give me 1 second. Draw the structure of S. What happens when you have dilute sulfuric acid added to it? What will happen? Dilute sulfuric acid. There's only
Hydrolysis, sir.
hydrolysis.
Hydrolysis.
There's only CN, right? So ये chart देख लो, इसके अंदर ना there's if you have a nitrile will turn into a carboxylic acid. It will hydrolyze if you add sulfuric acid in reflux. So that's what's going to happen. So ये जो product होगा, it's just going to be C and H. It's going to still be a polymer, except that it will be a polymer with a carboxylic acid now, and the whole thing will be repeating. I said next one. Name T. What's T? क्या नाम है इसका? This is it's an amine.
Is it propane amine?
You can write propanamine or propylamine. Both would be fine. Then you have and remember both are fine. Propanamine, propylamine. Sometimes the marking scheme says propylamine, sometimes it says propanamine, but both are equally acceptable. T can also be formed by the reaction of bromo propane with ammonia. So state the necessary conditions of what's the reaction halogenoalkanes reacting with ammonia? What are the conditions for that?
Is it NH3 plus ethanolic plus reflux heat?
So it's either NH3 gas in a sealed tube at high pressures, and it will turn into an amine, halogenoalkanes, that's nucleophilic substitution, or it's going to be reflux with NH3 ethanolic. So we'll just go with reflux and ethanolic NH3. As the next one. Question number 4, predict the bond angles X and Y. So carbon is making 4 bonds. What are the bond angles over here?
109.5.
Because this one is 109.5 degrees tetrahedral. Carbon is making 3 pairs of bonds.
Is it 120?
120, that's going to be fan-shaped or trigonal planar. Hydroxyethanol, this is hydroxyethanol. So it's an aldehyde as well as an alcohol. It's got both things. So will it react with 2,4-DNPH? What is 2,4-DNPH going to react with? Also, reaction with tolerance reagent and 2,4-DNPH and an observation. 2,4-DNPH. What is the test? What is 2,4-DNPH used for?
Testing for carbonyl compounds.
So 2,4-DNPH, it's this one. It's a test for identifying ketones and aldehydes both. And it will give an orange precipitate. So that's your observation with 2,4-DNPH. And since it's an aldehyde, if you react it with this other one, which is what's the tolerance reagent? What happens with tolerance reagent? Aldehydes, they get oxidized. So again, it's this reaction. Aldehydes, they will get oxidized by tolerance, and they'll give a black precipitate and a silver mirror, and they'll turn into carboxylic acid. They're going to get oxidized. So both tests are going to be positive. The 2,4-DNPH is going to give an orange precipitate. And this one will give a silver mirror and a black precipitate. Then he says hydroxyethanol is converted into ethane dioic acid when it reacts with dichromate 6. That's oxidation. So it's an oxidizing agent. K2Cr2O7. It turns orange to green. That's the color change. State and explain any other necessary conditions for this reaction to be successful. So what are the necessary conditions of oxidizing an aldehyde? That's reflux, right?
Heat under reflux.
Acidified and reflux, right? So heat under reflux. Acha, 2 likhi. I don't know why this is for 2 marks. He did write acidified. So what are the 2 marks for part C, right? The last part, just a second, 2 marks. Heat under reflux. And what's this mark 2 for? I said we had to explain as well. The explanation here for full complete oxidation, because reflux is when you reflux things. So he wanted the explanation as well. Why do you want to heat under reflux? So you want to for complete oxidation, because when you reflux something, the thing cannot escape the container because there's a condenser on top. It will keep on, even if it evaporates, it will fall back into the container. So for complete oxidation, for the complete or full reaction, that's why. We've got a reduction happening. The aldehyde can be reduced. So he's saying write an equation for the reduction of this thing, hydroxyethanol, to this thing. So we've got this thing, which is what it's CH2 OH, and on the other side it's CHO, and it's turning into CH2OH and CH2OH. So reduction is happening. So you're going to use H as the reducing agent, and I guess it's going to form kitne H's on this side, where that's 1, 2, 3, 4, and on this side I've got 6. So I'm going to have 2H, and there's going to be a water molecule that's going to be formed because there's fewer oxygen on this side. The oxygen's pure hai na?
I don't remember water being formed in reduction.
You're going to add water if the equation is not balanced.
Ah.
In this case, I don't think you need to add water because it is already, is it balanced or not? 2 oxygens, and over here you still have 2 oxygens. So everything is balanced. So you just have to add 2 H's because there were 6 H's over here. There are 4 H's. So I think that's the only thing you need to add. How do you reduce an aldehyde? That's 2 NaBH4 or LiLH4. So carboxylic acid to aldehyde, that is only LiH4, but aldehyde back to alcohol, that's it could be both NaBH4 or LiLH4. So we can go with NaBH4 in this case. ये याद रखना कार्बोक्सिलिक एसिड है ना, उसको रिड्यूस सिर्फ आप LiH4 से कर सकते हो. Next one is CH2OH also forms an alkene, reacts with cold dilute acetaldehyde KMNO4. Forms when an alkene reacts. So name A. So which alkene? It's probably going to be ethene because mild oxidation with cold KMNO4 happens. What happens in mild oxidation? That the double bond will turn into a single bond and it will form a diol. So this alcohol can be formed from an alkene if you have, just a second. So it will form an alkene if you, so the alkene is ethene, right? Is that clear? So is this clear?
Yes.
Yes.
So I think we're done with this paper. तो कल पे करते हैं.
पेपर पूरा कंप्लीट हो गया, अभी थोड़ा सा रहता है.
खत्म हो गया.
अच्छा.
चलो ठीक है. Okay then. Take care.
अल्लाह हाफिज.
Okay, thank you, sir.